I can do my own intro. Oh, I'm cool. I teach classes at Rice, so I'm very good about commanding attention. All right. So first of all, let me thank everybody for braving the traffic and staying for my talk. Zach couldn't be here today because sharks and cats or whatever. But anyway, we're going to talk about how to build a affordable infrastructure that you can secure in a Soho environment or at least at your own home. This is all pretty much based off of work I've done over the last 5 years building out my own infrastructure, and then also based off of Zach's experience when he's built out his infrastructure. So the crux of our problem is we both work at home in a home-oriented environment, so that means that we have to support our families, we have to support our own addictions of Netflix, TVs, PlayStations, Blu-rays, basically the Internet of Things, while also being able to conduct business in a secure environment that isn't going to be penetrated by one of our little ones bringing home an infected application or USB dongle. And unfortunately, the Soho market is very limited in the way that we can do things. Mainly, what I'm saying is mainly what I'm saying is there's pretty much the home market where you can go to Best Buy, buy a device, and plug it into your cable modem, and then that gives you wireless access and your switch ports. It's not very effective when you're trying to support a household full of a network of or Internet of Things. And then the other problem is you go to enterprise-size apps, which it's a price point that as a small office or small home office, I really can't find myself investing in. So that was the premise for this talk. So anyway, the overview of the talk is basically we're going to do a little bit of network engineering 101, talk about sourcing hardware and networking gear, creating an infrastructure that can be managed by one person or, if you've got kids, one of them, and then implementing that network so that it can be secured as you go along or as you start building out your business at home. Mind you, this type of template can actually be applied to a small office where it's like 10 to 20 employees. So it's not just for the home office, but it can be used for other people or other situations as well. So a brief introduction for myself. I'm a PhD student. I've done information security. Well, I've been working in information security for almost 10 years. I like to call myself a hacker. It's great for parties. It scares people, but it also intrigues them. As part of my research at Rice, I'm working on Java memory forensics, which seems kind of awkward, but it's actually kind of cool. And then scaling memory forensics when you start talking about large number of hosts simultaneously analyzing memory. And then I also work on other security stuff like reverse engineering and that sort. But one of my hobbies is network engineering because I have to support my own household. So like I said, Zach couldn't be here because he decided to dress up in a shark costume and eat cats. I just kidding. He had an engagement come up and he couldn't make it, and he apologized for not being here. So building a network is pretty straightforward once you understand what all the different what all the little knobs are. In general, the way we look at it is you're going to start with your ISP. Basically, they are going to give you a router or some sort of device that connects into the demarcation point. Then you're going to have your router firewall that you use to semi-manage your network. You'll definitely want switching. And as I mentioned before, if you go to Best Buy, you buy these little devices. Everything's contained in there. 10 years ago, that was really cool. Today, it's almost unmanageable when you start thinking about extraneous issues that we'll talk about later. And then if you're really special and you want to host virtualization for your business, or for maybe you want a machine that you don't want your kids you want a machine that your kids can use without actually having to worry about reinstalling it every time. So then you can use a virtual template to let them get on the internet and play their internet games. So traditional Soho products are basically going to Best Buy, last time, purchasing a device, and this device is all inclusive. It's got its own little firewall, it's got its own little switch, it's got its own little router, And then a lot of times you don't have the ability to go in there and configure or change the software because it's custom firmware, it's custom hardware, and it's really difficult to maintain, especially when you start talking about growing with a family or growing with a business. There are other options where you can go, okay, I'm going to flash this device and I'm going to put OpenWRT on it. But the problem with doing something like that is OpenWRT doesn't work the same way on every device. An example is OpenVPN. So one of the things Zach and I tried early on a couple years ago was setting up OpenVPN so that you can do point-to-point communication for malware analysis. This is a big deal for me because I wanted to do malware analysis at my house, but I didn't want it coming from my house. I wanted it coming from the Rice network. So I went out and bought 2 OpenWRT devices and tried to set up a remote peer between the two, a remote access peering connection between the two. And it failed. It was an abysmal operation that failed, and I couldn't figure out why. But what it turns out is, after reading some of the documentation, that part of OpenVPN didn't make it into OpenWRT. And that's really difficult to I guess, cope with when you're trying to get stuff done. So the alternative solutions are like, okay, well, I'll just hit up eBay and I'll buy a Juniper little device and then I'll plug that in. But then, again, you run into the same problem. I don't own this device. I don't have any support. I have to learn all the generic terms of Juniperese or Ciscoese or Palo Altoese, and it gets frustrating. And I say that you should never buy first-hand equipment if you're buying it on your own because of the price point. If you get it secondhand off eBay, you're paying 25% of what the business paid, and that's actually a great savings, especially when you start talking about $10,000 or $15,000 servers. So one of the great things about enterprise applications and enterprise systems is they come with really neat features. They give you the ability to do interesting things on the web interface. They come with the ability to do VLANs not just by port, not just by port, but by MAC address, by type of device, type of service. These are really great things that you might want to do when you start, trying to control where your children are on the wireless, or where your children's wireless devices go. So if your child moves from the family room to the media room, and they're using Facebook or whatever, you want to be able to control that. Okay, well, this type of traffic should be segmented from the rest of my important stuff. Or Netflix is also a really good example because you don't want Netflix eating up all of your bandwidth. So I kind of broke everything down, or Zach and I kind of brainstormed this, and we decided like what are the requirements that we really need to define a good SOHO architecture. First of all, it needs to be securable and extensible. Typically, when people start talking about I want to build a network, it's kind of like, well, I want it to be fast. I want it to do fun things, and I don't really care about security, but we've seen how that's all failed in the past. So going out of the gates, securable and extensible. The other thing is it's got to be easy to grow and easy to tear down. What I mean by this, like going and buying COTS devices like routers and such, it's great, but when I need to upgrade or add more memory or make it faster, it's bad, because that means I'm dependent on this one device and I can't go in, solder on some more RAM or add another processor. So we want to be able to build our own hardware or build our own gateways, but then we also want to be able to understand what the software is doing inside there. For instance, having a good community support system or having a good documentation system that you can go and rely on. And the other thing that I think is also should be made abundantly clear, it's got to be like low power consumption, because these things are always on. And believe it or not, if you go and buy a huge gateway interface from a major vendor, half the time that when those things were designed and implemented, if you're not buying it firsthand, chances are the power consumption is going to be on order of what a high-end workstation is. And that kind of adds up, especially when you start running a whole bunch of these things. So a couple of other interesting points to keep in mind is where are you going to put the devices, where are you going to put your rack. Typically, if you're building a new house, I highly recommend getting with a contractor and figuring out a closet space where all the communication equipment is going to be located, because then you can actually run HVAC and suck out all the hot air versus blowing the hot air with humidity up into the attic with a space heat or a spot cooler, which is what I almost had to resort to doing. The other thing is ISP. Like how flexible will your ISP be if you say, I'm going to plug in my application gateway interface or application gateway to your internet connection? Sometimes they won't allow this, so you got to kind of make amends and figure out how to at least get their stuff to talk to your stuff, and then you don't have to the point where you're just basically moving traffic or packets back and forth, and then you don't have to worry about anything else. And that was one of my earlier experiences with AT&T with their 2-wire system. They wouldn't let me put my PFsense firewall as the primary connection at the endpoint for my modem, so I actually had to rig the 2-wire to actually forward all the static IP addresses to my PFsense box, and then use CARP to actually make it recognize that I am these IP addresses and not my 2-wire system. And that was kind of like one of those motivator points for me to move away from using commodity hardware from ISPs and from places like Best Buy, because you can't control stuff like UPnP, and that gets really scary. The other thing to consider are virtualization requirements. I'll talk a little bit more about virtualization requirements when we get there. So in general, we've established that the modern SOHO should have a dedicated firewall that should be manageable from command line or from HTTP, and same thing for a switch. So switches are kind of like that gray area. So Mikrotik, one of the switches I would recommend, tends to be closed source, but it's based off of Linux. Doesn't make any difference. But I think the great thing about Mikrotik is it's still low power and it's easy to get your hands on for real cheap. Other considerations are racking, shelving, cable management. I did a price analysis at some point, and I found that like with the Mikrotik you can get a ton of great features in a switch. Typically what you would see in a high-end switch for a couple $1,000s. Like Delta 6220, I bought off Craigslist for $200. It was a great switch, but it ate a lot of power, put off a lot of heat. And this is what kind of motivated me to move from high-power, high-end switch to low-power, medium-end switch. It comes with a lot of features, and I'll talk a little bit more about them in the future. Zach tends to use the XyXL. Again, it's not a lot of horsepower, but it gets the job done, and it comes with a lot of features. So budgeting. So this is kind of where the metal meets the road. And I think for as much money as I've spent on hardware, when I actually put this number on paper, I was impressed. Not impressed because it's a big number. It's actually a very low number. When you talk about total cost of ownership and how often you're going to migrate to a new device or change out for the next wave of wireless. So in this case, I built a PFsense box. It's the equivalent of a $2,000 application gateway offered by PFsense. I built it for $550. Pretty awesome. So it comes with 16 gigs of RAM, 8 cores, Atom processor, the new Xeon D or whatever they call it, 2 manageable switches. So the reason why I have 2 manageable switches is for office segmentation and home segmentation. Funny story, when you start blasting gigabytes of multicast, you actually can't control it on the switch, even if you put IP firewalls in place, or IP filter in place on the switch. So I actually had to segment my network so that I could block off all of my multicast traffic and isolate it in my office. And I also wanted to increase the number, or increase the size of jumbo packets. So with the CRS 125, I highly recommend the switch. It says 200. Zach found it for 190. It's a fully functional switch. It does everything that I could ever dream of and more. If you wanted to, you could actually use that as your router, and it'll communicate. You can remotely log into it using OpenVPN and then DNS or whatever. I don't do that. I don't trust it. I don't trust embedded devices. It's just something I've learned to do. The CRS 226 it's a little bit more high end. The reason why it's a little bit more expensive is because of the jumbo frames that I can do with it, and it comes with a bit of faster processor. The wireless APs I'll explain a little bit more in the future. But basically, what happens is I have my firewall, I have my distribution layer for the switch, and then I have my 2 access points, and I plug all that in, and that gives me this nice infrastructure where I can work from anywhere in the house, or I support my family, and then I support all the devices that are involved. And the other thing that I include in my price is a PoE switch. I'm not trying to sell you anything. I'm just trying to show you the numbers so that you understand where I'm coming from. So when you start talking about virtualization, when you want to add this to your infrastructure, the reasons why you would add virtualization is it allows you to create new IDS sensors, create syslog servers, and create other data aggregation and analysis environments, so you don't actually have to run all this stuff on a workstation. The tricky part is sometimes you'll be I/O bound. Basically, you have too much data coming in on the network, and so you get packets dropped or whatever, or you're disk bound, disk bound, where basically you're just dumping a whole bunch of data to the disk, and no one else can write in a timely fashion, so you're dropping more packets. CPU bound, like you're basically trying to do a lot of data processing or analysis, and you just don't have enough CPU power to actually do all the processing you need in a timely manner. And then memory bound, you basically have a whole bunch of data that you want to load into the memory so that you can do processing fast versus reading it off the disk, which is 10 times slower, or 100 times slower. So that's one engineering requirement you kind of got to get nailed out of the gates. And then the other two questions are, like, what kind of applications do you run, and do you want to run everything on one box or multiple boxes? Generally when we design when Zach and I look at the design for our virtualization servers, we kind of consider like two different things. He looks at ESX, I look at Linux KVM. I like Linux KVM because it's easy to install and there's no licensee conundrums. Like Zach likes ESX because it's beautiful. Like it does everything you need it to do. It's got a pretty GUI and it's easy to understand what's going on. And with KVM, you just don't get that. I mean, Virt Manager is okay, but it's a clunky interface. The other thing I should say is, for me, a must is always being able to configure things using scripts or programs. And so one of the great things about KVM is you can use libvirt from Python, or Python's libvirt extensions, to actually manage VMs, bring them up, tear them down, create a new image from baseline image, stuff like that.
So there's no vendor lock-in on either one because it's live virt?
No. So
or should it say vendor lock-in?
Yeah, I should say vendor lock-in on ESX. My bad. But you can use ESXi, but I think there's some limitations to ESXi. So just to give you an idea of like an example virtual server that we would look at, 72 gigs of RAM for $399, and then you get 16 logical processors. More than enough, but this comes with the cost of heat. And just finding out how to disperse all that heat is a challenge, or can be a challenge. So final tips about like sourcing hardware. You should never buy new hardware unless somebody else is paying for it, because it's going to depreciate. It depreciates like mad. I shouldn't say like mad, but it depreciates very quickly because of the fact that IT has this like turnover every year or two. You're either doubling your speed or you're increasing the capability of the hardware and the software that drives the chip or whatever, microcode or whatever. So it's really important that you kind of take a step back and say, do I really need the fastest, newest thing, or can I look back 2 generations or 2 or 3 years and get something that's maybe 25 to 10% the cost? And again, when you're starting to look at this stuff, if you're looking 2 to 3 years back, you might also have this problem with heat. So spot coolers might be something you have to look at. So anyway, I probably took way too long to get to this particular slide, but this is the general layout of what I envision. This is how I design my architecture. So basically, on the bottom here, we have our family room and our media room. It's got our access points that connect, that hardwire into the TV and the Blu-ray players, or the Xbox and the TV. And then you have your wireless access point. So blue is like, this is me in my circular sphere of fun and work, and then my family's mobile devices, and then I've got my guest access. The important thing here is the great thing here is with Mikrotik you can actually create 2 different APs, 2 virtual APs. The first one being your internal one, and then the second one being your external one, where you can let guests log into. The other thing is, when you use PFsense, you can set up VLAN trunking, send the VLANs up to the PFsense box, and then you can run a captive portal on your PFsense box. So that means you can also constrain and control the traffic that your visitors or the load that your visitors are placing on your network. the other thing that I have here is my office where I run my virtualization servers, Bro and Snort, and then System Logger. Basically, I have direct access into the PFSense so I can actually do ingress and egress traffic capture and analysis. And then I also tie back into the switch so that way I can talk to stuff that's on the home network, like a printer. So it kind of becomes important. Basically, what this comes down to is my house is now a small office, and I'm not only supporting myself and my business needs, but I'm also supporting my family and their business needs. And that's kind of an important consideration, especially when we start moving into this idea of Internet of Things. So the idea of a piecewise, so this is where we kind of break into the doing the actual work stuff. I typically do piecewise infrastructure installation. I'm sure everyone does, but this is the way I learned it. I've never really worked in a formal position where I've had to do this. But anyway, the whole point of that is this entire process is about 2 weekends worth of work. So basically, you're out $1,500, you've got this hardware sitting on your floor, and you're really excited. How long is it going to take me to implement all this? It's going to take roughly 2 weekends. That's actually pretty big, especially when you start trying to budget like your time that you're going to spend with your family, which is again, one of the big reasons why we thought about this. So the rough time requirement for deploying or for installing and deploying a PFSense, it's about an hour. It's quick, easy, and it gets the modifications you have to do to PFSense are minimal. I think the most challenging part about dealing with PFSense is actually dealing with the web interface and realizing that certain menus aren't in the places where you would think they were. So, go ahead.
How long did it take you to build
The infrastructure?
the
PFSense Box? It took me an hour to put so to actually put the PFSense box together, it took me 15 minutes. Got my RAM, got my processor, screwed it into the box, and I'm done. I sourced my parts from Newegg. So my PFSense box is probably one of the few things that I've purchased new. I purchased the motherboard new. It was what was it called? It was a system on a chip, Atom or Xeon processor that came with the super micro board. And then the only mistake I made is I didn't realize it, but the super micro board requires ECC RAM and not non-ECC RAM. So ECC RAM is server RAM. And so I basically bought laptop RAM, and I tried to plug that in, and I couldn't get the box to boot for a couple minutes, and I debugged it, and I figured out I had the wrong RAM. So just basically went and purchased the RAM that I needed, and yeah, blam, came in the mail, and then I put it in my 1U case, and I was done. So 15 minutes. So 15 minutes of actual work, and then I guess Home Depot runtime, it took me about a day. But actually building and installing the PFSense box, it's really easy. It's just got to get all the parts together, I guess. Mikrotik distribution switch, that one's a little bit more challenging. One, because it's got a lot of features, kind of intimidating, learning your way around. But the documentation is really good. I used one of their, I don't want to call field manuals, but case studies. Read through it a couple of times. That's where the 1 to 2 hours comes to mind, because they talk about how to do everything from the CLI or command line, and then I like trying to do everything from the web. And I eventually just say, screw it, I go to the command line and get it done. VLANs are a little bit more tricky. The reason why I do have 2 Mikrotiks.
So the 2 hours includes both?
No, just one. Just one.
learning curve?
Yeah, learning curve. Yeah, definitely. It's all about learning curve. The 0 to 4 hours for the VLANs is the principal challenge is actually getting VLANs to work, talk appropriately to each other, and then forward up to the PFSense box correctly. PFSense, like once you get the VLAN tags created and the interfaces created and then mapped onto the NIC, PFSense is done. That's it. It's easy. When you start trying to do VLANs with Mikrotik, there's a couple of like knobs you have to turn to get everything right, but like once you do, it's like pretty easy. And once you master like what everything should be, it's pretty easy. It's like I said, or like the gentleman pointed out, it's the learning curve. And then the wireless APs, like I bought that literally one day from Amazon because it was like these OpenWRT APs are not working for me anymore. Plugged it into my network, logged into the Mikrotik, the wireless Mikrotik AP, set up the VLANs for my virtual APs, set up the management interface on Etherport 1, and I was done. Like, it works. So all the investment from basically these three things makes this a cakewalk. And I say 0 to 1 hours because I didn't want to put 0.5.
So can we leverage your scar tissue here and get it done in 2 hours altogether?
Potentially.
I don't know. Are you documenting all this, or are we able to
Yeah, so my
configuration files open source or
You built a PFsense from scratch.
yeah, I just use the standard install image.
Okay. I mean, you knew where to get the parts.
Yep. And I mean, I can share that with people. What I did was not closed source. The one thing I'm really hesitant about sharing is my configuration scripts because it's got my IP addresses, and I don't want people climbing through my network.
You need a way to
Yeah.
do X.
But I'm happy to help and show and guide. So installation of PFsense Box is really straightforward. You basically turn it on, install it to the disk, and then when it comes up, you specify which NIC you want as your WAN, and then which NIC you want as your LAN, or if you have multiple NICs, it'll help you identify it. You go through that, it's like 5-10 minutes. And then once you boot it up, you plug in your laptop, and then you go in and you update the firewall.
Still on UVert?
Huh?
Are you still on UVert?
No, we moved, and so now I'm on consolidated cable, which is another kind of pain. So I have fiber to the house, but they're still running ADSL, so I can only get 5 megs up. First world problems, sorry. 5 megs, yeah.
5 megs.
Right. But it's great.
One Netflix stream, and all of this stuff comes to a halt. Right?
Actually, no. So the great thing about PFsense is I can do traffic shaping, so I can actually shape the traffic that goes in and out of my network. So I can actually guarantee that if I need to remote access, I can remote access. There's no problem.
Your kids are watching the greatest Netflix stream.
Yeah. Well, right now it's just my wife and my baby watching Dragon Tales, but I'm sure they'll live. Dragon Tales in HD is just not what it's cracked up to be. It was never made for that purpose anyway. But I digress. The great thing here is it takes 10 minutes. You have remote access, and you can VPN into your home, and it's awesome. You can't do that with any other device that I know of, like COTS at Best Buy. Anyway, that's not what I meant to say, but that was my thought. So one of the big things that I always recommend that people do is swap your SSH and your HTTPS ports. The reason why is when you go to visit a site and you need to access your server, and perhaps the web interface is down, which I've experienced a couple times, being able to SSH and use the command line is important. So if you swap out the SSH ports, people really don't look at HTTPS traffic because they just assume it's encrypted. And if you're using SSH, they don't know that you're using SSH because they don't do traffic analysis sometimes, most of the time. And so this is actually a convenient way to actually be able to SSH to anywhere you need to. Anyway, so I think I covered everything on the slide. Awesome. So Mikrotik is the next step. It gets a little bit tricky because there are some warts inside Mikrotik that I just haven't really been able to pinpoint, and I can't say exactly what the problem is. But when you use the web interface, it has this option to change from router to bridge mode, or bridge mode to router mode. It's this whole cloud switch concept. I typically leave it in router mode, but I want it in router mode so that I can have a management interface for which I can actually connect to and manage it from the web. But I also don't want it to route any traffic. So I have to go in and manually turn off the routing part of it, but I have to assign an IP address so that I can still access it like it's a router. It seems confusing, but it's kind of the way a lot of these layer 3 switches work. It's not unusual for switches as this goes, but it's a little bit harder to set on Mikrotik just because maybe someone hasn't explained it the right way to get them to change it. So I've included a nifty little command that you can use in your console port, and that will actually manually set the IP address, and then you should be able to access it from your PFsense box. So the great thing is, once you have the IP address set for the Mikrotik and it's plugged into the PFsense box, everything is pretty much uphill from here because you got your VLANs. Sorry, but that's like the major hurdle I always hate doing. So the VLANs. Oh, actually, before I move on to that, we want the Mikrotik device to be secure. So I haven't really assessed what the different services do. So I only go with the standard. I leave SSL open and I leave SSH open. In order to run SSL, you have to create certificates on PFSense, export them, convert them to PEM files, and then import them into Mikrotik. And the important thing here is to make sure that NTP is turned on for your Mikrotik device, or Chrome is going to freak out and you won't be able to connect because the timing difference will cause Chrome not to be able to determine, or will cause Chrome to think that you're doing being man in the middle. It's pretty straightforward. Anyway, setting up VLANs, it's kind of an onerous task, and I can't speak to how hard it is because I'm just a unique individual. But I can say that this particular guide is actually your savior when you're trying to do this. So I've documented it, and I will share the slides with anyone who's interested, and I'll post it on Google Drive and then blast a link on Twitter or whatever else I need to. So testing to ensure that your VLANs are set up appropriately. You can't really see it, but I have close to 100 devices, virtual machines or whatever, on my network. And when I originally was doing my VLAN testing, I didn't know how to appropriately gauge whether a VLAN was working correctly or not. The great thing about PFSense is you can actually specify for each VLAN what network range you want your device, or what network range you want your VLANs to fall into. So then, if you do that, you can actually go into your DHCP leases, plug in your cable, get an IP address, and then see where your IP address falls. So if you get an IP address for the appropriate VLAN, you know you're working well. The other great thing about Mikrotik and VLANs is it lets you, and you can do this with most other switches, but having a lower end switch be able to do this is kind of important. You can have untagged packets. You have untagged packets that actually get tagged with the port VLAN, or you can have tagged packets that don't get tagged when they leave the interface, but then you can actually do stuff like the two different APs on a switch port, if that makes sense. So basically what happens is you have the ability to do untagged VLANs on a port, but you also have the ability to do tagged VLANs on a port, and you don't have to do any fancy Q and Q conversion in the switch. That's what I'm trying to say. Anyway, so the wireless access points, really easy. Take them out of the box, assign a WPA2 key to them, and then set up the guest APs, and then you're done. Fantastic. Yeah, super easy. So some of the words I've documented here is basically what I've reiterated, or a reiteration of things that I've said previously. It's really difficult to get the IP address set up on the Mikrotik, but once you do, it's easy to get running. Sometimes, if you don't have the IP address set correctly, or if you set it dynamically, it causes, if you ever have a power failure, it'll cause Mikrotik to go into this weird mode where you actually won't be able to get to the switch, and it'll break all the VLAN stuff. So setting everything manually is important. So rookie mistakes. I think the biggest rookie mistake that I encountered here was actually making modifications to the firewall rules without actually updating or making modifications to the management interfaces without updating firewall rules, and then attempting the installation without a console cable, because I ended up blasting a whole bunch of stuff and it was hard to get back in. So after the walls go up, a couple of things that I haven't done but I think people would be interested in doing. Setting up Freeradius. So basically, Freeradius gives you the ability to do 802.1x authentication within your home network, and you don't have to worry about giving people passwords to get onto the wireless anymore. I always have a hard time giving my wife the Wi-Fi password because it's super long, and she always makes fun of me when I tell her what it is, and she types it in on her phone, and she's like, "Is this it? This it?" And it's fun. It's a crazy long password. It drives her nuts. Anyway, the other thing you might want to do is, like, if you're having guests, or if you're tired of like giving out a static guest network password, you can actually set up a captive portal, have people register, and you can actually create a honeypot around it. Fun things to do. Some other things that I would have liked to do on my PFsense box, because I had a lot of extra horsepower, is install the IDS to do ingress and egress traffic capture and just basic analysis and ship it over to a syslog server. And also incorporate event information so I can do more detailed analysis. But alas, I only have so much time. So monitoring and analysis, this is another big part. This is kind of where the virtualization falls into play. So basically, the idea is to create some type of understanding about what's happening on your home network in conjunction with the work that you're doing. Typically, it's easy to go out and buy an appliance, plug it in, set up all the web interface, but that's expensive, and who wants to do that, especially when you have to consider support and licensing. So one of the best ways that Zach and I have kind of found a way around this is getting a virtualization host, $400, and then setting up VMs that do specific sensor-oriented things, like a VM that does snort, a VM that does bro, a VM that does event aggregation, and then feeding that down to an NFS mount, and then doing data analysis on top of that.
You said you get a virtualization host for $400. Is that software or hardware?
Hardware. So basically, you go to eBay, type in, X number of gigs of RAM, or what I typically do is I build stuff from spare parts. But basically, go to eBay, find a nice little server that's within your price range, and then buy that, and then install whatever software you appreciate most. Zach will say ESX. I'll tell you Linux and KVM. But then once you do that, that's your virtualization host. And you can, these days you can buy really great hardware at a pretty modest price and do really great things. So one of the hard questions I had to answer when I was going through this whole process is, how big of a host do I need? How much memory is required? What do I really need versus what do I want to buy? And what do I mean by this? It's so for me, I like to go big or go home. But that's not really cost effective, nor is it really power conscious. So Zach and I kind of came up with these rough numbers of what we've experienced. So we've said, okay, if we're creating just an IDS host, and that's all it's going to do is IDS, then maybe half a gig of RAM to a gig of RAM, and then 1 or 2 cores, per 40 megabits that we're going to be analyzing, because it's a home network. It's not going to have a lot of upstream. So you can get away with a lot of stuff that you wouldn't get away with in an enterprise. Networking and logging, same thing. Low CPU load, low data flow. So again, you can go really cheap. Where you're going to really want to beef up your numbers are when you start doing data aggregation and visualization. Several reasons. First of all, you're either going to run a database that's going to be network oriented, or you're going to run an in-memory database that's going to read all the information in the memory, and then it's going to have to query everything. So if you have small amounts of memory, if you've got a small memory assignment or allocation to a VM, but you have a big database that you have to read in, that means you're using swap space. That means that not only are you using swap space on the KVM disk or KVM machine, you're also using disk space on the virtual host. So you've got two hardcore, two bounded reads, which kind of slows everything down. So being able to create a big memory allocation for a VM and then do the visualization and analysis is kind of a key thing to consider. Now here I say 1 to 3 terabytes of RAID 10 for disk space. That's my recommendation. Zach does a lot less. He does it on 1 terabyte. But I've had a couple of applications where I've basically needed 8 terabytes RAID 10. RAID 10 is RAID 10. That means you have to buy 4 disks for every terabyte. So if you're going to do 1 terabyte, you need 4 terabyte of disks. However, if you're building something that requires a lot of fast disk speed, disk read, and fast disk write, then RAID 10 is pretty much the best thing you can do. People have said, well, why not raid SSDs? I actually don't trust SSDs enough to want to raid them. And they're really great for scratch space. So what I typically do, and what I have at home, is I have slight digression. I have an SSD scratch space plugged into my server, and so I just read files off the network onto the SSD, do data processing on the SSD, and then do storage on the RAID 1.0, which is actually kind of an interesting setup that I never would have encountered had I not had to do large-scale memory analysis. You're going to have to excuse me. I'm on cold medicine right now. I'm slightly congested. So one of the big takeaways here, always engineer for failure, and then you can go cheap all the time.
And what do you, volatile mean, the SSD, what you were just talking about?
Oh, so volatile disk. So in your VM, when you build your VMs, you don't really want to build them with a lot of disk space that you're going to be writing long files to. You don't care about it. And what happens is if you make a VM with a small disk, once it runs out of disk, the services are going to start to crash. So what you really want to do is you want to mount the NFS and save all the volatile data that you care about on the VM to the NFS mount. So that way you can just grok the NFS mount for what's going on the host, and then you can just blast the host when you're done with it. Does that make sense?
So in that sense, volatile disk is the logic.
Yeah, so what I mean by
Which
volatile
means you
disk,
could-
just
if
like
you
it's,
lost them,
yeah.
not a disaster, that kind of thing.
Yeah, well, it's just not, it's volatile data that you care about, but you don't want it like wrapped up in the virtual machine. You just want it like saved else. You want it saved directly to the virtual host that's hosting the VM versus in the VM itself, because it saves you from having to worry about running out of too much disk space. So for me, when I got started with some of these projects really early on, one of my big things was, oh, I want to check out SaltStack, or I want to check out OpenStack. But I didn't really need that, and one of the problems that I ran into is I spent all this time building machines and infrastructure to support that, and then when I finally got it installed, it either A, didn't work the way I wanted to, or B, it was just overkill. So one of the things I found is I can actually save a lot of money if I just write my own custom scripts and my own dealybobs around libvirt and just use KVM. And it's actually worked out pretty well. But I do use the DevOps principles where basically create stuff that I can baseline and duplicate very quickly so I can scale. So some other questions that might come up when you're doing this is, or when we were putting this together, we were like, okay, so what happens when we start talking about doing moving from like, we've established our infrastructure to I'm going to do really interesting things that I might not want other people to realize what I'm doing, like malware execution. This kind of comes down to how do you want to do your malware analysis, and it's either you want to do it at home, but you don't want the network to originate from yourself. So what you do is you create a PFsense box or an execution environment in AWS, run it there, pull back the logs, and then you don't have to be concerned. Or if you're doing stuff like fuzzing or experiments, you might need more specialized infrastructure components to deal with that. That was kind of actually outside the scope of this talk, but we wanted to kind of throw that out there. Anyway, so just to conclude everything, we went over how to implement a basic, securable, extensible architecture for Soho. We kind of pushed the use of Mikrotik and PFsense, mostly because of the community and the documentation surrounding it. It's easy to get a hold of, and it's affordable. And then we kind of motivated this initially that along the lines that enterprise class hardware may not be suitable for home environments because of heat and then cost constraints. Anyway, any other questions? Or, well, I'll appreciate your time and any questions? Yeah.
You had a data aggregation bullet a couple slides back. Do you have a preference for database for data aggregation?
So I like to roll with Redis, but for like the visualization stuff for sensors and such, there's SQL, Squiggle or Skeagle, and then there's ELSA. And I'm not not too familiar with like their data backend, but when I've had to do software analysis, basically scanning through process memory, enumerating where pointers might be in memory, I've always used Redis because Redis reads everything into memory, and it's very, very fast because of that. Well, it's very fast because of that, because I'm not like touching a disk or going through network I/O to get anywhere. And then, so if you use something like Redis, and then you use a simple web server with, what is it, D3 JavaScript, you can actually build some pretty cool visualizations, which a lot of people have. So as far as data visualization, data aggregation, I just use packaged products, and I just put them on a individual server where it runs. And then that server is just hard-hitting because of the size of RAM and the number of cores it takes. Any other questions? Again, I appreciate everybody.
Is the presentation going to be up on HouSecCon.com?
If that's where it needs to be. Okay. Yeah, that's where it will be then. Thank you.